I'll record our session so that our friends who are going to join us tomorrow, in spite of going through everything again, we can just pass on this legacy to them so that we are saved of our time as well as they also don't suffer. We have 6 more friends who will be joining us tomorrow. They were supposed to join us today morning only, but somehow they missed their flight yesterday. So they would be landing up here in Nairobi by today afternoon, around 2:30 something. So from tomorrow morning they will be joining us. Okay. So here, so forward, so these are the directories which we have on all the Unix environments. This is all Unix environments. All Unix environments means either it is a proprietary Unix or it is a open source environment based on Linux. So / is my system root. /boot is the operating system loader and kernel directory. /usr, just do ls/usr on your systems. Just do ls with all these directory names, one by one. In Unix, everything is a file. So how my devices are managed here? When I say everything is file in Unix, it means everything, which means your keyboard is also file, your monitor is also file, your hard disk is also file, your processor is also file, your CD-ROM is also file, everything is a file. In Unix, everything is a file. So where are all these files registered? All these files, you are visualizing nothing else but the files only. And all devices, which you call up as the hardware components, all hardware components, physical components are registered inside the path /dev. We call it up as device database. It's something like my device manager in Windows, where you can get in the listing of all the devices connected to your Windows server. The same way here in my Linux, all my devices which are connected, starting from clock generator IC to the biggest peripheral component connected. Everything is registered here. Your system clock, your processor, your RAM, your memory, your virtual hard disk, your physical hard disk, everything is here. So if you do ls/dev, you get a listing of some names, some of the device names, which might be quite easy to identify, and some of them might not be easy to identify. Are we able to get that? When we did ls space /dev, this is dev means devices. So you have your FC also there, you have SR also there, you have your HDD, SDD, lot of device names there. That's it. Can you identify some of the device names? /CPU, okay, dev/CPU 0, CPU 1, CPU 2, something like that, depending upon the number of cores on your system. CD-ROM is identifiable, okay. You have your FD0, okay, then you have your dev disk. Dev disk is for all the storage devices, block devices. Your hard disk, your SAN disk, everything will be referred through your dev/disk. There are multiple ways of identifying your device names. To be more specific, storage device names, like dev/disk by name, by ID, by path. If you check the contents of your directory dev/disk/, then you will get those. We'll talk in detail about that when we are talking about our storage administration. Okay. So here, my device database. These are common to all the Unix platforms. All means all Unix platforms. Now the directories which are specific to Linux world, which you will find only on the Linux operating systems, on all Linux. So things which are specific to Linux are my /sys kernel state database of all the devices /proc kernel state database of all the processes / applications running on server. Okay. Sys is my kernel state database of all the devices. I cannot use a device unless or until my kernel does not identify it. My kernel needs to identify the device. Then only we will be able to access it. If my kernel does not identify, I cannot access it. So this would be useful in which scenarios? If in case you published a storage, or the storage team says that they have published the new logical unit or a SAN block device as per your request. Let's say you place a request for 10 GB of more space for your Oracle database to the SAN team. And the SAN team guys, they said that, okay, we have published the new storage and we have mapped the storage to your server. But on your system, you cannot view a new disk space. When you are checking the /dev, there it is showing the device. But when you're checking your disk management, it's not showing you the device there. It's because the system kernel has not yet updated that device here. So every device which we are working upon need to be registered with my system kernel database also. And proc is a database of all the processes. Just run the commands ls/sys and ls/proc. I'll be asking you to run so many commands. So what is the difference which you visualize here? In case of sys, you would have noticed only some directory names there. Like sys/class, sys/scsi, sysnet. Are we having like that? So related to your network stack, related to your storage stack, related to your process stack, there will be multiple devices here. The same way, when you check ls/proc, here you get a listing of n number of directories having their names as numbers. Is it? Are we getting a lot of numbers? Sorry. All these numbers are nothing else but the process IDs of all my running processes on the system. Every program, when it runs on a Linux system, is assigned a unique identification number. Sorry, which we call up as my process ID or the PID. This PID you have in Windows also. When you go to your task manager in Windows and click on the details of all the processes running, you get this column there, PID. Like in Windows, you have the process name and the PID number. Every process having a unique numerical digit assigned to it. The same way in Linux also, when you run a program, be it a program executed by you or the program which is running at a background as a service, is always having a unique number to it. The contents of your slash proc directory are nothing else but these numbers. So these are nothing else but the active process IDs, active PIDs of all the programs which are presently executing on your Linux box. So slash proc is the kernel database of all the processes or applications running on the server. Mind one thing, it is only for the running processes. If a program is terminated, it does not have its registry into the proc. So any program, if it has to be executed, it has to be firstly registered in slash proc. Then only it can run, otherwise it cannot run. Slash media mount oblique access point for all external storage devices, that is block device oblique optical media. So your CD, DVD, USB flash, external hard disk, everything will be registered in slash media. Slash net is like network neighborhood. Do you have a directory by the name SRV?
Yes.
Okay. We'll talk in detail about the SRV directory when we manage the services here. Okay. So what all directories we have here? Forward slash. So in Linux, I'll be having all of them. All of them are there in Linux. Above are specifically to your Unix. So we have forward slash, we have forward slash boot, we have forward slash USR, we have forward slash etc, forward slash bin, forward slash sbin, forward slash mnt, forward slash home, forward slash lib, forward slash opt, forward slash dev. In Linux environment, one more directory that you have there is slash root. This is profile path of administrator. So unlike Microsoft servers, in Linux world, your administrator stays as a different home than the unprivileged users. Like in Windows, C:users is a path for your administrator's profile as well as for all the users. In case of Linux and Unix, administrator's path is different. So Linux world, my administrator's home directory is slash root and all other users home directory is slash home. Slash home is the path of profile for all unprivileged user accounts, or you can say user accounts created by administrator. And slash root is the directory for administrator's profile. So slash home is the admin home, and slash root is the admin home, and slash home is the home for all unprivileged user accounts. Okay. There's one more directory that exists on all the environments, and it is your slash lost plus found. Something like recycler. It's not the recycle bin, but something like recycler. Okay. So the directory structure of my Linux is clear to everybody? So when you do a ls /, the names which you visualize now you know the meaning of them. And why do we have these directories on our system? Is it clear? So when everything is file in Unix, what is the advantage? Why we do not have files and devices separately as do we have in Windows? As in case of Microsoft environment, we have our files and devices managed separately. Whereas in Linux and Unix, what we say is that everything is files and files are managed the same way. So what is the advantage that we get? And second question that comes is, if in case everything is file, then how my Linux kernel identifies user data from the process, from the device, and from the storage? Because everything is file. So my process is also a file, my data is also a file, and my device is also a file. So how my Unix system or my Unix kernel identifies the differences between them? So Unix says that everything is file, but files are of 7 different types. In Unix, everything is file, but files are of 7 different types.